Hi, my name is Olivia Marchand, and I did my science fair project on plastic insulators. Here's my abstract if you would like to read through. Okay, so introduction. Athletes will choose water bottles that will keep their water coldest for the longest period of time. No athlete wants to come off a field, court, or rink and have a hot, non-refreshing drink of water. There are many potential types of plastic options to choose from when an athlete is choosing a water bottle, but the athlete will want to choose the one that serves as the best insulation and will keep their water coldest for the longest period of time. So here's some background information about my topic. Transparent plastic water bottle, when exposed to sunlight, the liquid inside will be exposed to the sun's rays as well, making the liquid heat up more quickly than a non-transparent bottle or aluminum bottle. The clear bottles act as a lens and magnify the sun's rays, which also lead to the quickening in the rise of temperature in the bottle. Polyethylene is a type of plastic made from ethylene gas, which is the basis of multiple different types of plastic. Here is the difference in the densities of the type of plastic. The two that I will be testing in this experiment are low density polyethylene and high density polyethylene. And you can also see the difference in the chain branching. So here's some more information about polyethylene plastic. Low density polyethylene melts at about 230 degrees, and high density polyethylene melts at about 266 degrees, which shows a difference between the two types of plastic. High density polyethylene, HDPE, plastic is a flexible, strong form of plastic that resists cracks and has a high impact and melting point. Tritane copolyester plastic bottles have high energy and thermal insulation. Polyethylene trithopolate is the most commonly used plastic when manufacturing water bottles. The reason behind this is because of its strong material and that it has the ability to prevent oxygen from entering the bottle, as well as it keeps the contents free from going bad from exposure. This type of plastic is used to make the Aquafina water bottle in this experiment. So, yeah. And more background information about this topic is the temperature is measured in kinetic energy within a system. The kinetic energy is in the molecules and atoms of the system. The faster the molecules inside the water move, the more kinetic energy that a liquid has, and the more heat it has. So the hotter the liquid is. As water gains heat, it gains kinetic energy transferred from another surrounding heat source. Convection is the movement within a liquid in which heat rises and the cold falls, and heat is less dense as cool air or cool water is more dense. Okay, so here's a characteristic chart of each of the type of plastic insulators that I'm testing. So LDPE, low density polyethylene, and HDPE, high density polyethylene, Fiji, Aquafina, and Poland Springs. So as you can see, all of these plastics are transparent except for the LDPE, which gives off a cloudy look. And here are the cap colors, just that you can see the physical description of the type of bottle. And then all of these bottles are BPA free, which is a good thing when going to choose a type of water bottle, because BPA is an industrial chemical used to make certain types of plastic. In recent research has been found to lead to cardiovascular problems as well as fetal and infant health effects. This harmful chemical can leach from the container into what is inside. So you would not want to have a BPA bottle because it could have bad health effects, be harmful to your health, basically. Okay, introduction to the purpose of this experiment. The purpose is to find which type of plastic water bottle keeps the water coldest for the longest period of time. The results of this experiment will have numerous benefits. Not only will it help allow athletes to maximize their level of refreshment mid-workout, but it will further scientists' knowledge on different types of plastic, allowing them to determine which plastic they will use as an insulator in a future experiment. So my research question is, what type of plastic insulator keeps 16 ounces of water the coldest for the longest period of time? My hypothesis is that the high density polyethylene will keep the water colder for the longest period of time. This is because polyethylene plastic is non-transparent, so it will not magnify the sun's rays like a transparent water bottle. And all of the other types of water bottles in this experiment are transparent. And then the high density polyethylene is thicker than the other plastics and has a higher density. Any type of external heat will take longer to cause an impact on the interior liquid through conduction, radiation, and convection. So the materials used in this experiment are a thermometer, Poland Spring 16 ounces, Aquafina 16 ounces, Fiji 16 ounces, low density polyethylene bottle 16 ounces, high density polyethylene bottle 16 ounces, and a fridge that is set to 40 degrees Fahrenheit, as well as tap water. So the experimental setup, the independent variables are the volume of water, the temperature of the fridge, the type of plastic. The dependent variables are which bottle cools the fastest and the slowest, and the temperature of the bottle throughout the experiment, and the starting temp of the bottle, which is 40 degrees. The control is the bottles are placed apart from each other to reduce the risk of conduction, which is shown in this picture of the experimental setup. So this is the Poland Springs, this is the Fiji, this is the low density polyethylene, and this is the high density polyethylene, this is the low density polyethylene, and this is the Aquafina. So they are in the same environment, and I did this experiment at night, as you can see in this photo as well. This is to eliminate the factor of the sun's rays affecting the temperature of the water bottle, if at all it was exposed. So that decreased the amount of error in the experiment. And then the caps were off for the same period of time, and the bottles were all measured in 2 minutes, 2 minutes, 2 minutes. The procedure was to empty and clean each of the water bottles. I did this because different types of water bottles might have different types of minerals that could affect the outcome of the experiment. So Fiji might have a different minerals in it or than Poland Springs. So I wanted to reduce the chances of error by replacing them all with tap water. And I measured this tap water to be exactly 16 ounces, whereas some of the bottles, they came as 16.9 ounces of liquid. And then I refrigerated them all until the water inside reached 40 degrees Fahrenheit with the thermometer. And then I placed them all in the controlled environment with no sunlight exposure and at a temperature of 60 degrees, which is the stopping time for where the stopping temperature for timing when they reach that temperature. I stopped taking the temperature of the water bottles. and then I placed them evenly spaced apart from each other. And then I observed and measured the temperature drop of every 2 minutes. Okay, so here are my results. So when averaged the time to minutes by the type of plastic bottle, it is shown that LDPE takes the longest period of time to heat to reach 60 degrees, and followed by HDPE, then Fiji, Aquafina, and Poland Springs. This chart shows the change in temperature over time by the type of plastic. As you can see, they all start at the same temperature, and the Poland Springs, which is the blue line, took the shortest period of time in a time frame of 60 minutes to heat up, while LDPE took in this time frame, heated up the least, so it stayed cold. So my discussion, the results when averaged out show that the LDPE kept the water coldest for the longest period of time. However, the trials show that HDPE kept the water coldest for the longest period of time in the 3 trials that I performed. This is because in HDPE won 2 of the rounds, whereas LDPE won 1 of them. So HDPE had a total of 184 minutes in its longest round and 138 minutes, while the trial that DPE stayed coldest for the longest period of time was only 116 minutes. The average rejected my hypothesis, while the trial supported my hypothesis. The potential sources of error in this experiment were the time frame in which the measurements were taken. This could have messed with the averages, and if they were not measured correctly, if there was error in the measurements with the temperature, if it was giving me the wrong temperature, and if the caps were being open for too long, and then conduction through touching the water bottles could have caused heat transfers from my hand. And then what I would change in the experiment, when I was test the water bottles in an environment in which the sun's rays were a factor, so that athletes that play sports outside, like soccer or field hockey or lacrosse, could know which type of plastic bottle to choose. And then I would change the surface area of the water bottle. This is because the Poland Springs water bottle had it was shaped like this, whereas the LDPE and HDPE had a surface area like that. So it took a longer period of time from conduction for that heat to get to the center of the bottle, whereas if in Poland Springs, it would take a shorter period of time because it was closer to the center of the water bottle. My conclusion is that the data points to the conclusion that HDPE and LDPE keep the water coldest for the longest period of time. This is due to both types of bottles are manufactured out of thicker plastics that serve as better insulation. The thicker a plastic is, the longer it takes for the outside environment and temperatures to affect what is being contained on the inside through transfers of heat, conduction, convection, radiation. And thinner plastic is more susceptible to heat transfer. Conclusion part 2. In order to increase the number and rates of sales for a company, plastic water bottles should be manufactured using HDPE to ensure the water concealed inside the plastic is kept cold for a long period of time. This would be better for athletes and for workers. It would increase the sales of a company because the athletes want to choose the water bottle that will keep their water refreshing throughout the whole game or practice. And conducting an experiment as an insulator, HDPE is the best option to reduce the amount of heat transfer. And here are my sources. Thank you.